mic test you because I had it turned way up.
They can hear me. I can hear me.
Really? I can't.
Yes, we're good.
Okay. So yeah, it's just on the wireless only.
Hi, everyone. My name is Ian Stokes-Rees. I'm a computational scientist at Continuum Analytics. I'm very happy to be here today. Continuum is one of the sponsors of the Boston Data Conference. We've worked with John on some other events in the past. We're happy to be here as sponsors this week. My colleague Bradley is out at the table there today, and I'd love to get to talk to anyone here who's involved in Python data analytics. So out of curiosity, how many people here have heard of Continuum before? Oh, I love to see that. Okay, how many people are using Anaconda right now? Fewer. All right, so if you want to get Anaconda, Anaconda is a packaged Python distribution, platform specific. It includes everything in the Python standard library, Python interpreter, as well. It includes a whole bunch of additional pieces, a bunch of tools and a bunch of additional packages compiled for your platform, so you don't have to mess around with build chains and dependencies and getting it so all these bits and pieces work properly together. At continuum.io/downloads, you can get a copy of Anaconda. You go to python.org. Who wants to show off their knowledge about how big is the Python installer from python.org? Anyone? Take a guess? 20, yeah, okay. We got 20, we got 54. It's right about in the middle. It's around 35 megs, round figures, about 35 megs depending on your platform. You go here, you download Python, it's going to be a lot bigger. It's about 250 megs. It wouldn't be great if everybody in this room started to try and download and install Anaconda right at this moment. Okay, we're all on the same access, where there's only a couple APs in the room here. We'll totally saturate it. However, when you get back home later tonight or maybe at some other point, this is a fabulous way for you to get not just Python, but a whole bunch of great tools like the Spider IDE, like IPython, like NumPy and Matplotlib. IPython Notebook is packaged in there, a bunch of additional development tools. You get stats models, and you get all of the main pieces for Python-oriented data analytics. So continuum.io/downloads. You're free to use that for any purpose you like. The companies you work for are welcome to take that, install it on 10,000 machines, and use it for commercial purposes. It's free for everybody to use. So you guys enjoy that. Today, I am going to be giving a tour of data visualization libraries in Python. Now, the schedule has shifted a little bit. I was expecting to start at like 10 to 2. It started a little bit after 2. Is an organizer here able to tell me when I have until? I should have asked that question before I stood up here. Are you aware? I'm not sure. Okay. Somebody have a schedule in front of them there, wants to tell me how long I've got till? And while someone's looking in that, you just shout it out when you've got that information. 2:40? Okay, great. So I am going to give a very brief, as part of sponsoring. I was happy to give this talk whether or not Continuum was deciding to shell out some money to be a sponsor and get us a table here and so on and so forth. Since they shelled out some money and we have a table here, we've got a bunch of stickers and some other stuff to give away there. We want to also ideally get to connect with you guys a little bit more. So meet us at the table, talk to me afterwards. My colleague Brad will be here tomorrow. Unfortunately, I won't be here tomorrow. Additionally, if you leave us a business card, or here's the deal, if you don't have a business card, if you write your name, email address, and maybe who you work for if you like, on one of our business cards, then also take one of my business cards. If we get your name, we will be giving away at the end of the day today one of these fancy little portable standing desks. So this is actually a friend of mine who's designed this on a Kickstarter project. So it's, let me see if I got it right here. I do have it right here. There we go. Portable little standing desk. If you give us your name and email address, you have a nice little, this thing can hold up 1,000 pounds. It's pretty cool if you look at it. It's stand.us. Anyway, there's some stickers and stuff out there. So this can hold up 1,000 pounds. It means you can hold up your laptop. If you give us your name and email address at the end of the day today, we'll pick one out and you can get one for yourself. Okay, with that little introduction, additionally, I'm going to take a couple minutes to tell you a bit about Continuum before I go into my tour of Python data visualization libraries. The talk that I'm giving, the majority of it is available at this URL, okay, j.mp/pyviz-1h. Pretty easy to remember, j.mp/pyviz-1h. So this is an IPython notebook. How many people here are familiar with IPython notebooks? Pretty good crowd, right? Okay, good. If you're not familiar with IPython notebooks, that's what I'm going to be using when I show off these Python data visualization libraries. For the Continuum part, however, I'm going to jump to a very quick keynote presentation to tell you a little bit about Continuum. So, Continuum would like to be to the Python data analytics world, or to the data analytics world in general, actually, what Red Hat was to Linux. Red Hat facilitated an ecosystem, brought together a whole bunch of pieces to make Linux really something which wasn't just for hobbyists and geeks, but something which could be used very, very widely by a broad range of people, by individuals, by startups, by large enterprises. Continuum would like to provide the same sort of, facilitate the development of the same sort of ecosystem for high-performance computing, data analytics, and visualization. We believe that Python is the best general-purpose language to bring all of those pieces together. And so we want to facilitate those pieces coming together really, really well. Because right now, if you go out there, not just in the Python world, in any piece of the data analytics ecosystem, you either have very large 20th century companies with very established business models and verticals for the tools that they're building, or you have 21st century startups who are building some really, really cool technology, but often it's very inaccessible. You can look at it, you can look at a YouTube talk, you can come to something like this and see somebody give a nice talk on it, but in practice you can't actually go off and use those things practically yourself. You need to go and install all of the Hadoop infrastructure, you need to go and install some kind of fancy AWS deployment. It's the kind of thing that IT groups and big companies with budgets of tens of millions of dollars can dedicate like a 6-person team for 3 months or 6 months to bring together the software engineering skills, the analytics skills, the system administration skills to bring all of those pieces together. So what we're trying to do at Continuum is to make it so that all the pieces can fit together really well. We're trying to also fill in gaps specifically in the Python ecosystem for data analytics, high-performance computing, and visualization. So, Continuum Analytics. We're about 50 people or so. Company's only about 3 years old, based in Austin, Texas. Until a few months ago, I lived here in Boston. It's been my home for the last 7 years. We've got my colleague Brad also lives here in Boston. There's a few others of us who work remotely. I just moved to Syracuse, so unfortunately I'm no longer exactly local, but I'm local enough that if you have a serious interest in some of the things I'm going to be talking about in the next 5 minutes, please get in touch with me afterwards, because I'm happy to come back here to Boston to meet with you, to give a talk at your company, to talk about how data analytics, Python-centric data analytics can work for you. Okay, Travis Oliphant, creator of NumPy. He's a mathematician and computational scientist extraordinaire. He's very, very bright. NumPy is the foundation of all scientific computing in Python, if you're not familiar with that. And Travis brought together some numerical libraries that existed in the Python world and brought them together into NumPy, and it is to this day used very, very widely. Travis is one of the founders of Continuum, and Peter has a lot of background in high-performance computing, scientific computing, and a number of visualization tools. Peter's real passion is around visualization and is the conceiver of Bokeh, which is one of the libraries that I'm going to talk about today. Let me jump through some of these pieces. This is for a longer talk, and I'm trying to give the quick version. So Python is great in that it spans a very broad range of users. It can work for people who work in scientific computing, for people who are are trying to do serious high-quality software development. It can also work for people who are analysts and would never consider themselves computer scientists. Maybe they've heard of source code management before, but they've never used it. They've never used Git or Subversion or anything like that, even though they can write some code. Python is a great language because all of these people can come together around the language and work together. So you don't end up with like barriers between your Java developers and your C developers and your R analysts and people doing stuff in SQL or in SAS. That's the very quick pitch for Python. And NumPy is central to all of these things within the Python ecosystem, millions of users. Anaconda brings together the binary libraries compiled specifically for your platform. And through conda packages are not specific to Python. They're general software packages that you can install as a regular user. And you can also provide a sandboxing mechanism. Probably lots of you in the Python world are familiar with virtualenv. Well, virtualenv is specific to Python, and it's specific to the version of Python you happen to be using. With conda, without making use of virtual machines, you can sandbox the versions of R you're using, the R packages that you're using. You could sandbox different Java. You could sandbox different Java interpreters. It's language agnostic. It was inspired from Python, but it's language agnostic. So it combines both the features of pip and the features of virtualenv. And it does it without being specific to Python. So that's part of that's conda, and conda is part of what Anaconda provides. The packages in Anaconda are all provided as these conda packages. So similar to Yum or RPM or these kinds of things. Okay. Anaconda Server is one of our commercial products. It lets a large company manage deployments of Python on a whole bunch of computers. It also provides a cache for things like CRAN or CPAN or, of course, PyPy, so that an organization could say, you know what, you can't just go and pip install anything in the world. You can only install things that we've cleared, or you can only install things which are under a license which is compatible with the development that we're doing. We don't want to corrupt our code by ending up with, I shouldn't use the word corrupt, that's an unfair word to use. We have to be careful not to use a word, use a license, which is going to mean that all of what's supposed to be our proprietary development, we're going to be stuck legally having to open source because of the license terms of code that we've linked against. Anaconda Server allows large organizations to do that. Binstar.org is like GitHub for binary artifacts. It provides a namespaced, access-controlled package repository. So imagine if you had your very own space within pip, or your very own space within CRAN, or if you're a Perl developer out there, your very own space within CPAN, where you could put packages in, you could version stuff, you could have different, you could have one which was compiled against MPitch, and one against MPI, and one which didn't have any MPI support, or one which was optimized for AMD, and one which was optimized for Intel, different versions, just for you and your friends. This is the kind of thing that Binstar provides. And then you can just conda install it. So Binstar is a free service that we provide with commercial variants available for you as well. We're putting into it a build system so you can write your code in one language, and our build system will then build it against a few standard platforms, 32-bit Windows, 64-bit Windows, so on and so forth. Wakari. You're going to see me using Wakari today. Wakari is a web-based data analytics service. It provides a centralization of a whole bunch of tools so that people just with a web browser and an internet connection can access Python, R, Julia. We've got Hadoop on there. Go, not yet Go. Go is only in our development system. So Wakari brings together a bunch of tools through a web-based interface, lets you do some publishing. So the j.mp/pyviz-1h, that's actually taking you to a published version of my notebook. That published version has no outputs yet. Anybody who's browsed there, you're going to go, where's the visualizations? Well, we're going to generate the visualizations. When this session's done, I will republish the content. You're then going to have the copy of the outputs as it stands at the end of this session. Wakari Enterprise is a fully in-house version of Wakari, and we're looking to sort of span everything from cloud-based deployments, desktop-based deployments, cloud-based deployments, and enterprise-based deployments. So data analytics happens in a lot of different places. Through Anaconda and Conda, you're able to sync those up really, really well. You're able to provide a set of package specifications and data specifications, synchronize those, and have an environment that travels with you no matter where your computing and your data happens to live. Okay. Key open source technologies, Blaze, Bokeh, and Numba are packages. Blaze for distributed data modeling, Bokeh for interactive visualization, Numba for just-in-time compilation of Python code to via LLVM to run blazing fast on standard CPUs and GPUs. And I'm going to skip through these because I don't want to spend too much time on them, but there's some pretty cool stuff you can do with Numba right now. 150 times speed up. I'm not expecting anybody to be able to read this code right here, but simply by putting an @AutoJIT decorator in front of plain Python Mandelbrot routine, it runs 150 times faster because it does a just-in-time compilation and then runs it using the C-compiled version via LLVM, and it happens really, really fast. And I'm going to skip over slides about Blaze. Blaze is at an earlier stage in development. Blaze is the next generation NumPy. It's the best way to put it. And Bokeh I'm going to spend time on a little bit later. This just shows off some of the visualizations, so I won't spend time on these right now. Good. All right, well, that was maybe slightly more than 5 minutes, but not too far off of it, I don't think. Let's jump over here. Okay. Oh, my Wakari session disconnected while I was presenting. So there's a timeout on there. So Wakari has a free tier. In the free tier, you get 1 gig of RAM, and you're split. I think we load up 30 people onto 4 CPUs. So you get like a whatever that is, like 1/8 slice if the node's under full use. On the free tier, you get better. If you're prepared to pay, you get more RAM and more CPU on Wakari, and you get about a 15-20 minute session timeout for using the software. Let me close my tab here and say don't save. Here. So this is Wakari right now that I'm inside. So shut down Wakari, or shut down that notebook. Okay, so there are more libraries than this. There are more visualization libraries than this in Python. In particular, off the top, I'm going to mention that I'm not talking about MPL3D. MPL3D, D3 translates matplotlib graphics, in which you are going to learn about. We're going to spend the first sort of third of our time looking at matplotlib, which is sort of the granddaddy of Python visualization tools. Translates matplotlib graphics, so everything we're going to see in the next 10 minutes, translates those into JavaScript D3 visualizations, which then you can build in interactivity to and things like that. So I'm not talking about MPL D3, which is relatively new in the past year-ish, maybe it's a year and a half that MPL D3 has been around. I'm also not going to talk about some of the great tools that exist for cartographic mapping and visualization in Python. There are some fabulous ones out there. And there's a third one I'm also not going to show off, which is 3D visualization. There's some code samples in here, but I'm not going to run them due to time reasons. So Myavi is one of the main libraries for 3D visualization in Python. So I'm not talking about exhaustively. Those 3 in particular are worth mentioning that I'm skipping. But we are going to cover a bunch of interesting ones in here. And there's references and hyperlinks to each of them at the top. So how many MATLAB users are there in the room? People who've written any MATLAB code at any point in their life? Quite a few people, a lot of people. Okay, so I'm an engineer. My background's electrical engineering. I then ended up doing a PhD in particle physics computing. And between physicists and engineers, I've used tons and tons of MATLAB. I love MATLAB both for the linear algebra stuff it can do for numerical algorithms, and I love it for the visualizations I can produce. I've produced some really massive, very sophisticated visualizations in MATLAB. But like most people, my work with MATLAB got to the point where it wasn't just for me. I was trying to produce things where actually I wanted to have interactive graphics. I wanted to have graphics with little features. I wanted to have them built into pipelines and workflows, or I wanted to tie them in. I spent 8 months on an internship where I was trying to tie in my MATLAB code for real-time radio frequency analysis. And so I was doing some work developing assembly-level code to actually do very fast, high-frequency radio analysis. And then we were doing sort of the visualization piece using the Visual Basic and MATLAB interfaces to the C libraries to produce the results. Things fall down as soon as you start trying to really build MATLAB into applications, in my experience, and I think in a lot of other people's experience as well. Matplotlib attempts to take the interface that we're all familiar with MATLAB and the graphics that we all know and love from MATLAB and produce the same graphics with the same APIs as much as possible. And so Matplotlib is a Python library which gives us access to as much as possible an API, a compatible API with the same look and feel. It's got a model of figures, axis lines, decorations on figures, color maps, subplots, the ability to do 3D plots. These are projected 3D plots, so they're not exactly dynamic, but they're 3D projections of plots. There's some links here for the Python Matplotlib tutorial, Matplotlib gallery. The way you get access to the MATLAB-like interface is through this pyplot library, matplotlib.pyplot. We import that in Python as PLT. This just gives us an alias to this namespace in the module, which is where all of the methods are going to be. So whenever you see PLT here in the rest of the code in the next 20 minutes or so, we're talking matplotlib. If somebody says to you pyplot, pyplot is a sub-module, sub-package of matplotlib. NumPy is this library developed by the CEO and my colleague Travis Oliphant, and it is provides the most commonly used data structures for numeric numeric computing in Python, as well as a bunch of functions that operate efficiently on ND arrays. So it's got multi-dimensional sign functions. Math.sign only works on scalars, floats, and integers. NumPy's sign will work on an n-dimensional array. So whenever you see NP as a prefix to a function, NP dot something, NP is the alias to NumPy, and then we're in NumPy land. Okay, my first little example here is simply showing an exponential decay of this function. So if you're not sure what an exponential decay is, you're going to see a little picture of it in just a moment. But that's the function describing a noisy exponential decay. This is a general algorithm, and X is the observations based on this model. And so here we've got some Python code which describes this exponential decay. We've got the n number of data points, the a underscore n is the amplitude of our noise, and t is our time constant in seconds. Well, there's no units here really, but we could say it's seconds. This generates a linear space from 0 to 15 and 200 sample points. So we've got 200 sample points from 0 to 15. And then here we have our signal. So this part here represents the first part of our algorithm, and then we've got a noise part, which is the amplitude of our noise times the a random noise signal. Our observations are then our signal plus our noise. So I need to import. I need to execute. When you see the numbers here, that means that cell's been executed. These have no outputs. So there's nothing to see except that it's done. If there's a star there, it means that it's still running. And here we now have our first little example of creating a figure using Matplotlib. We create a figure, we generate a plot, X are our x-axis, our observations, our signal is our observations, and R is a color indicator. Give it a title, X label, Y label, and we save the figure into 2 different versions. So let's run that, see the output. So a little bit of code here, and we're able to produce a pretty nice figure. We're able to save a PNG version, which is good for the web, and a PDF version, which is good for publications. We could build that into a LaTeX file or something like that. So usual sort of, anybody familiar with MATLAB, and there are a lot of you, will see that this looks almost exactly like MATLAB commands for the way this was all generated. And the figure, you'll also see, looks a whole awful lot like a MATLAB figure. Oh, I already have output here. Oh, I executed twice when I did the last cell. Okay, and here we just generate a histogram of our noise. So this isn't of all of our observations. This is just a histogram of our noise. So we can see the normal distribution of our 200 in 20 bins. So we can change that to say we wanted to do 50 bins, or say just 10 bins. Histograms. All right. Matplotlib is our foundation for plotting in Python. We're going to use this little story about the Trojans and Spartans. Has anyone heard the story of the Trojans and the Spartans before? That would mean, were you at Compute Fest in January run by Harvard? Because I gave this variation of this talk. No? Okay. So this is going to be a little made-up story about the Trojans and the Spartans and how a recent contextual, historical, and archaeological study has revealed new insights into the comparative ferocity and empathy of the ancient Trojans and Spartans. Hundreds and hundreds of objects and entities have been categorized according to these two measures, ferocity and empathy. And a new model recently published in the Journal of Computational Mythology. Unfortunately, everyone is having some trouble interpreting the results. Python data visualization to the rescue. All right. So we're going to be dealing with 500 items from Sparta and 150 items from Troy, SN and TN. And then the rest of this here is just giving us a correlated set of observations for these two data sets. So just like we had amplitudes and noise and so on and so forth, we have the same kind of thing for our Spartans and our Trojans in terms of offsetting the distribution of these data. And this here is giving us a correlation matrix, basically. And at the end of the day, we're going to get our S and T's here, our observations for our Spartans and our Trojans. Okay, we've got our data. We've got two data sets. A data set for S, a data set for T. Let me give us here cell above S dot size, S dot shape, 500 by 2 for our Spartans observations, and T dot shape. So for each item, we have two measures, a measure of ferocity and a measure of empathy. And that is what these that's what these two matrices contain. So let's try and plot ferocity versus empathy for each data point. Here we go. Plot X versus Y for the Spartans, plot X versus Y for the Trojans. I guess we get a line plot by default, and each point is connected in order. So this doesn't look very good. It looks like a 3-year-old squiggle. The solution, change the marker to an O. So we just add that O statement there. And now we get something which is a small improvement. Not a big improvement, but it's definitely improvement, easier to interpret. So along the way, we discovered that this is really a scatter plot. Matplotlib provides a scatter function. So let's try and use it to change from plot to scatter. So we don't need to do those O's now. We can just do scatters directly. Great, but not so great. Because scatter doesn't automatically use different colors for subsequent overlaid scatter plots. The solution explicitly provide the marker color. And this is kind of ugly. We have to specifically, it's got a different parameter signature on scatter. We have to specifically say C equals, and C is for the color parameter. Nice thing about Python, named arguments. Named arguments actually makes your code a whole lot more readable. So this is saying we want our Trojans to be blue. We want S, our Spartans, to be red. And we plot those data sets. Outstanding problem, which data set is which? Solution, label, and legend. We put labels on our data sets. That automatically labels the plotted data sets. And then we add a legend to our figure. Getting there. Trojans and Spartans. We're on a roll, but legend is in the wrong place. And we've got no axis labels or title. So what are we going to do? We're just going to do a whole bunch of things all at once. We do X label, Y label. We put the legend in the upper left. We add a title to it. And now we've got something which is looking better, except we've buried those Trojans behind the Spartans. So what do? We add an alpha channel, common technique to have some see-through visibility and also to have some color stacking, as alpha channels mean that as the colors are overlaid, the projected color darkens. These are pretty small, but at least we have a little more visibility through our data set here. So carrying on. New data, object significance. New data comes in, and we now have a whole new set of data for our object significance. We're going to use the significance to affect the size of each object. So we've got data points of ferocity and empathy, but we want bigger circles where the significance of that observation is considered to be more important. So what this is going to do is just give us an additional dimension for every one of our, so we now have three-dimensional data. So this is our new data. What are we going to use? Use this to change the size of each data point. So that is here. S is the size of each plotted data point. This can be a scalar value, which means all points will be the same, or it can be a vector of the same size as the data that we're plotting, and then our data points will be lined up one by one so that they correspond. So we look at our data now. We have different sized circles depending on the significance of the data point. Quickly to show off a few other quick things within Matplotlib. Hexspin gives us a nice layout of a heat map for our data, and the same thing for our Trojans. Hard to overlay these, so these we do as two separate graphs, a heat map and heat maps for these. Okay, so that is a very quick overview of some of the things you can do in Matplotlib, some histograms, some heat maps, and some scatter plots. Prettyplotlib, one of the issues with Matplotlib is that it's meant to look just like MATLAB in every way possible. And MATLAB, really its visualization pieces were developed predominantly in the 1980s. What's the outcome? A lot of your graphics that are produced end up looking very much like 1980s graphics. Prettyplotlib modernizes a lot of these things. It's also inspired by Edward Tufte in terms of minimalist, not having signals, not having information in your plot, which is superfluous. And so it updates the look of your plotting. We import Prettyplotlib, and wherever you see PPL, we're using Prettyplotlib. And so here we're going to use PPL scatter instead of PLT scatter. So we're using all of the same, otherwise identical, except we're using Prettyplotlib instead. So Prettyplotlib provides a cleaner axis lines. It provides a different default color palette, softer colors, not such hard reds and blacks and blues, and changes some of the relative default font sizing. It also does things like on histograms. It uses white space between the fields as opposed to dark black lines between your histogram fields. So we have nicer looking histograms as well. And then finally, showing off within IPython, so this is an IPython specific piece. What I'm using here is IPython Notebook to show all these pieces off. We can do SVG display. And so what we have here is, I think up here I saved it. Yep. So I did a savefig hist.svg. And so it uses the extension of the file. Unless you explicitly say what format you want the file to be in, it'll use the extension to guess the format of the file. So this saves this file to an SVG. It's always with a projector a little hard to see these things. I've got a nice Retina display here. But even for me on my Retina display, I can see the pixelation on this particular plot. When I go down to this plot here, I get perfect display resolution for my SVG file. Of course, that also means that it's quite a big file that's produced. But I'd have sort of infinite zoom-in resolution on this data. Okay, carrying on. Seaborn, inspired by R, and it talks pandas data frames and NumPy ND arrays, and I'm just going to show you a very few little pieces from Seaborn. So we can do things like regression plot here for our Spartans. So here's a linear regression through our data set with our error bars based on the number of observations. So that's just a reg plot. D-spine automatically removes the top and the right bars, and if you wanted to be even more aggressive, you could do left equals true and bottom equals true. I think I've got that right. Yep. If you wanted to remove even more. Okay. Seaborn does a whole lot more than this, but this is just to make you aware of the most common visualization libraries. Now, I want to take a few minutes on Bokeh, but I also want to complete a few of these pieces before I jump into a couple minutes on Bokeh. Mayavi, I said I'm not going to show off, but there's some simple examples here that'll demonstrate to you on your own local system how you could generate 3D spinnable, zoomable visualization. So not just a static rendering projection onto a 2D plane of a 3D structure, but something that'll actually come up that you can spin and zoom and have multiple colors on and things like that. So this is some code that you could run. NetworkX. NetworkX is the library that is most commonly used for graphing networks. So here we have a simple network definition. We've got 5 nodes, 0 to 4. We've then got a 2-tuple describing the vertex of each of those nodes. And then what we have here is something which is drawing a set of those nodes. So node 4 here gets drawn in the default color, which is red. Nodes 0, 1, 2, 3 there gets drawn. You can see at the very far right there, B gets drawn in blue. And then this adds in edges onto each part of the graph that we've got. So here's this. Here's the graph. So you can vary the size of each node, the color of each node. You can vary the connections and the connection sizes and colors. So you can convey a lot of network information through NetworkX very efficiently. And your data structures don't have to be in Python. They can be in a more generic format that you could use in lots of different programs or could be generated by different programs but rendered in NetworkX. These are a few other examples. A star graph with a spring layout. Spring layout means push them as far away as possible. Oh, right, okay, so this isn't generating, this isn't plotting it, this just generates it. Here's our 21 points in our graph. Here are the edges. Edges just mean the connections, the abstract connections, not the absolute positioning. And here's what we get. We get it in this layout because we said it's using a spring layout. So a spring layout pushes things away from a central point. And here's a random geometric graph. So it's 200 points. This is the connectivity measure between the points. And I'm not going to read through what all of this code does, but this is generating a random graph, finding the center of the graph and then coloring the graph based on the distance of each node by the number of edges from the center. So random graph, kind of, what does that look like? Sort of an A, maybe you could say. We rerun it, we'll get a different graph out of it. Okay. So NetworkX. I don't even know what this one is. Oh yeah, okay. This is a big example. So I'm not going to read through the code, but it's to show a sophisticated example. All of the code to generate this is right here. So there's no other library that's being used except for NetworkX and the data file that's being read in. So that block of code, that's about, I don't know, 80 lines of code or something, is reading in a history of chess playing between the chess grandmasters. And so it spits out some of the results, and then here it generates this graph, and it's a graph which shows the relationship between the different players. And it says there, edge width is the number of games played, and the node size is the number of games won. And so just showing a much more sophisticated graph, a single code example of a much more sophisticated graph. And finally, I think finally, stats models. Stats models, there's stats models and there's ggplot. So stats models are going to give us, we're reading in here the R data set. So this is reading in data frames, R data sets that we are, this gives us the connection between education, income, and prestige of different positions, and then looks at some different kinds of relationships between these things. So this is our data. It's a pretty small data set. That's all of it right there. Here's our model, which is saying prestige is a function of income and education. And then we can test that. We can test that model to say how well that correlates. And so then there's our fit, and again, you see these things start to look a little more like what we see in R plotting. Ordinary least squares regression results being spat out for us, and then another fit, fitted values for versus education, education versus prestige. So that's from stats models. So stats models is a lot more than just graphing. Graphing is just part of what it does, is an output of the statistics pieces that it gives you. Last piece here before I show off a few pieces of bouquet. ggplot. ggplot, this is ggplot for Python. So it aims to replicate ggplot behavior from R. Wherever you see GP in my following code, it's ggplot. So here's a distribution of the MT cars data set, well known to anybody who does stuff with R. Not super exciting. Distribution of the data set, the number of measures there are for the different 4-cylinder, 6-cylinder, 8-cylinder cars in the data set. Gosh. The diamonds data set. Okay, so this is the diamonds data set showing the price versus the different kinds of cuts and the distribution of those things in the data set. So again, ggplot style plotting that we get from here. Plus you see things like you compose plots by using plus to add different elements to your plot in the R style. It still kind of confuses me the way that works, but that's the way R people think about composing their graphics. And step plot. And then and it measures interval, central tendency, and then the error bars on it. So ggplot. Okay, so that is covered like the main libraries that are used for data visualization in Python. I'm also now going to take just a couple minutes to show off bouquet. And this is going to be a more direct code sample view. We are going to look at, so we've been looking at scatter plots. Here is a bouquet scatter plot. We have here the first 3 lines of code. Let me come over here and point at them. Generate our number of points, our X and our Y. Just like we were looking at before, except there's no noise in these data points and the distribution is a sign. We output to the server. There's a default server on localhost that Bouquet is going to link to. Where is it getting these from? It's getting these from Bouquet plotting import star. So anything you see here that doesn't look like a standard Python command is coming because we did an import star right there. And so this is outputting to server an image called scatter. So here's our data. Here's the server, the output server that we're connecting to. And we're now creating a Bouquet figure. This is a Bouquet figure that's going to have these tools connected to it. And we're now going to create these figures, scatter plot, scatter plot, scatter plot, scatter plot, and we do a show. And a show doesn't mean a local show. A show means to our output server, which is what we've set up as our output destination. I should do these probably in 2 separate windows so I don't have to jump back and forth. We run scatter.py, and here we have a web accessible view of these figures. We're able to do box zooms onto these data points. We're able to do wheel zooms to zoom in and out, and we're able to do pans, observations such as that. Now these are not linked, so each of these is a separate plot. We generated 4 different plots. We jump back over here. We do r equals 0.1 times np dot rand n. No, it's rand n. Random.random, random.randn. Thanks. If we don't get there, we'll... And so here's our noisy version. Now, I'm going to be appreciative of the time and the fact that I'm out of time. I've just done a very short demonstration of what happens with Bokeh. I'm going to describe the features that Bokeh gives us here. Bokeh has 3 important components that are running at any given, that we need to consider in the operation Bokeh. We have clients, web server clients, who do read-only access to a server. There's a Bokeh server that contains 2 different kinds of things. It contains data sets for plots, and then it contains figure descriptions. The clients have a static set of JavaScript. Unlike other interactive visualization libraries, which generate JavaScript. They generate like a block of JavaScript for this visualization, a different block of JavaScript for different visualization, and if you tweak things, you generate new JavaScript. The JavaScript for Bokeh is always the same. Like the code for matplotlib is always the same. You don't go and change matplotlib when you want a new figure. You just use that library. Well, Bokeh just uses the JavaScript library. Bokeh uses the JavaScript library to query the server for a particular plot. Here, it's asking for the scatter plot. If I were to go and do Python burton.py, we've generated a different figure. If I go to the top of my server here, my server should be listing my scatter plot and my Burton plot, which are 2 different figure documents. Those figures can be embedded into a web page. The web page will get updates from the server when the plot changes, or it can just do a one-time load and not be doing a polling mechanism or be available to be dynamically updated. This gets the data and gets the plot layout from the server. It uses the static JavaScript, Bokeh JavaScript library to render the image. This allows the images to, this provides a lot of advantages. It allows the images to re-render when there are updates on the server side. It also allows the server to automatically decimate the data. So we have some examples, which I'm not going to run right now, but we have some examples where we have 1 terabyte data set of ocean temperature and salinity data. 1 terabyte's a whole awful lot. If you wanted to interactively visualize in your web browser 1 terabyte of data, you do not want 1 terabyte of JavaScript, of JSON going over the wire, because where would it go, right? Like nowhere on your laptop, impossible. So what happens? Well, your figure is only this big. It's only 400 by 600 pixels. And so the client says, I want to render the entire world's ocean salinity data and about 400 by 600 pixels to do it in. And so it's decimated on the server side. The server does strides and slices and passes back just the data at a resolution that can be rendered on the client side. As you zoom in, the client says, I'm zooming in on this data. If it's got the data at that higher resolution, it'll just render it. If it needs higher resolution data for the new resolution that's at, it'll say, hey, give me new data. I'm looking at this resolution now. And so you get updates appropriate to the resolution. So that's the web client for viewing the data, and that's also the server which is holding the data and the figure documents. The third piece is clients where we actually create documents. So we can have a service that's running that's constantly updating data in the Bokeh server. We can run, as I just did, I reran the scatter plot and it updated the server with new data. And so we have then an API which allows different services to update the server with the data. That's like a high-level picture of the components of what the Bouquet model provides. There's the Python interfaces, which are very concise. There's the client-side piece, which is static JavaScript. And there's the server piece, which you don't need to touch, which just holds the data for you and holds the figure definitions, which you're able to query. The last thing that I will mention is that you can also, with Bouquet, generate a single standalone piece of HTML. That HTML can inline all of the static JavaScript for Bouquet.js, as well as all of the data and all of the figures that are required. So in one single file, you have your HTML, you have your CSS for formatting, you have your Bouquet JavaScript that nobody needs to read or touch, you just trust us that it works. And then you have JSON, which embeds all of the figure information and the data information. And you then have an interactive visualization entirely in one file. Or the in between those two worlds, you can get rid of the Bouquet server and you can have a static piece of HTML that's referring to JSON files on disk, and they pull the files from JSON, not from a Bouquet server. And so you just update JSON on disk, and your visualizations, each time you reload, give you updates. And so Bouquet is a very, very powerful interactive visualization library. I've only spent a couple minutes showing it off. Happy to talk to you more about it. It's all available on, where's my link to it? Not on this page, not on that page. Bouquet.pydata.org gives you the documentation, and you can fork it off of GitHub. It's under active development. We've got a couple full-time developers working on it. We'd love to hear your input or thoughts on how you could use it. It's open source. We hope we'll have a commercial version of the server where we'll make some money so we can keep developing it. But the current server is open source, and what I've shown you is open source. I'm sorry I've gone a little bit over time-wise. Everyone, thank you very much. I'm happy to take some questions, but I think the best thing would be if you've got some questions for me, come on up here afterwards, and I'll take them for there. Thank you for being here today and tomorrow, and good luck with your Python-based data analytics. Remember to drop off a business card or leave your name on a business card if you're interested in a drawing for one of these. Standstand.us if you want to look at the Kickstarter page, if you want to get one for a friend for a Christmas gift.
Okay, a couple announcements just to make. Again, after the sessions today, we're going to be going over to a place called Mead Hall. We have a room reserved, appetizers and drinks up over there. Mead Hall. If you're online, you can Google the directions. It's basically in this direction over here. Before the end of today, I'll have a slide of the map of Mead Hall. And the second thing is the gentleman who, Andy, who has the sequel session, we have a question. Would you guys want to have a